save my videos on my combo classroom for being called that, but I mean on my combo class channel, where the next one will be an epic grade -2 finale. We'll call this just a series of live streams that we like to do sometimes, where we whip up crazy graphs. I am in my front yard right now, as opposed to the combo classroom, where I have actually been camping in a tent still, like on previous streams. That experiment is continuing. But right now, some of my neighbors were playing pretty loud music, and I don't really care if the music got in the background for aesthetic reasons, but I don't want to get the copyright system flagging any of the moments where I stop talking to gaze into a graph. In any case, today we're going to do a particular graph experiment, so let me pull open our Desmos. And in our graph experiments here, we like to use different combinations of different ways of putting together formulas like inequalities or equations, and we often do that in 2D, although sometimes we extend it to 3D as well for fun. And today we are going to use a unique combination of something that is ironically very related to what are called combinations. Combinations and permutations are two types of the most common formulas and things that show up in math related to arranging or counting items in what's known as combinatorics, or selecting items. And essentially, many of you may know, I've mentioned before, that the factorials, where you multiply all the whole numbers up to some integer, when we're using typical integer whole numbers in there, for example, 1 times 2 times 3 times 4 being 4 factorial, that is the amount of ways that we can count, or that we can order a set of n items. So if I have 4 balls and I have them on a shelf in some order, there are 4 factorial ways to do that. And there are other formulas related to, say I have some amount of items and I want to select just some of them, not necessarily all of them, and I want to see things like how many ways could I select 3 out of 5 balls, or how many ways could I select 3 where the order mattered. And these are permutations and combinations, essentially. And with our permutations, where we are going to select some ordered members out of a set, that typically only makes sense for whole numbers. But factorials can be extended via what's called the gamma function, and so we can graph the factorials because they extend them here. So even negatives and in-between values where it wouldn't normally make sense, we can graph with this extension, basically a slid-over version of what's called the gamma function. Now, because of that, the formulas for permutations and combinations, which happen to be built from factorials, are actually in here, in their list of options we could apply to things. For example, let's say I were to graph y equals x factorial divided by, in the denominator, I have x minus y factorial. I get this. Now, let's say I were to graph this thing called NPR, not like the radio station, but basically the permutations of n and r. And let's say I make it x and y. And let's say equals y, like that one. Same thing. You see, there's the red, there's the blue. So it turns out we have this different way of comparing two things that sort of makes this stacked factorial thing. And if we had combinations, which would be NCR, those are a bit different, but they are very related to the permutation formula, and if we're using both at the same time, we're at risk of them canceling out when we don't notice, or either doing twice the same thing or twice opposite things, which cancels out part of them. So today, we're actually going to be able to go crazy enough just with permutations. And another day we will save the aptly named, for combo class, combinations, and what they can do to graphs, which will be similar to today's. That will be the sequel to this one. I will at some point also make a main episode, probably on my combo class channel, about how permutations and combinations have these formulas, why that intuitively makes sense. So that will be coming at some point in grade -3. Will be an episode that is my official intro to permutations, but we can still use permutations with this extension of the gamma formula in the numerator and denominator of something. And by using these, we're going to be able to create some crazy shapes that may never have been graphed before. So thank you to anybody joining me so far. What we're going to begin with is going to be just turning this into an inequality, greater than or equal to y. And already we get this interesting pattern. We have different quadrants doing different things. This quadrant is completely filled in. This one has this wavy thing that sort of approaches stripes. And this one approaches a sort of slanted checkerboard. And down here, if we zoom in, we can get more details about these subtle waves that are really close to lines over here. So our quadrants are going to behave differently. We'll also notice some of them have gaps in common areas when we're fiddling around with this. I only fiddled around with it briefly myself, so most of what we're going to try, I haven't tried yet either. We are sort of just cooking with combinations, ironically, of permutations. Not actually cooking with the combinations, cooking with combos of permutations, and seeing what we can invent. Perhaps we can make shapes that look like landscapes, perhaps like strange mazes or board games, perhaps eyes or trees or stars. Keep an eye out for if you can personify any of the things we can see. Now, here, the first thing I think when I see this about how we could spice this up a bit is, why do we just have y on this side? We have x and y on that side. Why don't we have something like x times y or x plus y over here? Now, we still have this checkerboardy thing, but this fella looped around a little differently, and we have a very distinct line now, not as much at y equals 0, more so at y equals 1, and another one that approaches y equals 0. What if this was addition instead? And we get that. And sometimes we're going to want to make some clones of these so we can see similar patterns with a few variations, sort of layered. Sometimes when we layer things with a small difference, they fit in together well. So for example, just to see what happens if we were to switch y and x, and we'll see that we get a sort of symmetrical flip of it. It flipped it across the axis y equals x. The green and blue are flip versions of each other. What if, though, we had one of them both be the same variable, like y. Well, that changes that one significantly. And now, what we're going to try is having one of these be a little more. Like, what if one of these was xy there and xy there? Now, we get pretty busy ones. Let's see these one at a time. This one gets this similar to the checkerboard from before, but really slanted. And once again, we have that curvy thing, some little petals down there. And the main thing that I believe will go extra crazy, or there's two things I believe will go crazy, we'll try them both separately and together. One is going to be bringing in our good old trig functions, incorporating sines and tangents and such. And the other is going to be nesting this inside itself, having another permutation within here. First, let's see what happens when we have a permutation on each side. What about when the permutations of x and y are the same thing flipped? We get this. That's interesting. So this is a very simple equation and has quite a unique graph. Now, another fun thing to do can be to put a variable somewhere in here. Let's say the first one of these gets an a on each case, and then we can see this as one state of a sort of mutating thing. Whoa, these are crazy. It's growing these crystals. That's wacky how it changes. It's like there's this shrinking grid that is there of like this checkerboardish pattern, but other stuff is shrinking or moving at like a different rate than it and seeming to like pass by. And as we keep going, we approach this really crystal-y form. They grow like a crystal right there, and oh, maybe there's only some of them are crystals. Up here it's just spikes. All right, well that one's already pretty wild, that shape right there. So that was when we cranked it up pretty high. Let's set A back to 1 for now, so when we're not fiddling around, as long as A is multiplicative, it's not changing anything currently. So now let's see what happens if both of these were both. Whoa, even when that one's it's interesting. That's interesting too. What happens when we mutate this one? Well, here at 0, it hits sort of more boring. Well, 0, it does nothing, I guess. Near 0, it has a somewhat more boring looking state, but then it gets more chaotic. Maybe it was only boring looking from there. Maybe if I zoom out. We do hit weird glitches, but it's much more noticeable when I change the scale on this A. Whoa. Now that's pretty wild. And all of these little things are like unique little shapes inside each box. As far as I can see, they're all different than each other. Maybe some are symmetrical. So there might be flipped versions of each other. Now, let's see what happens when, as I said, we try mixing in some trig functions. We're just going to put this on one side for now, the permutations, and we're going to say that is greater than or equal to sine of x times y. Now we get almost kind of similar to before, but with some different waviness. This has a sort of maze-like structure it's forming. Here it sort of falls onto more of a grid. Here it has little splashes coming out, like a wave splashing. Here it's just sort of these rays. A lot of these, nothing happens down here in like this eighth of the graph. Now, here let's try if I were to put one in here as well. Whoa. So this is going pretty crazy. What happens when we zoom out? They start forming these little like stacks. Look at these little stacks of things. These look sort of like Christmas trees or something. Now over here, you got some waves splashing, and this, I don't know what to call. This is just crazy. These are crossing over each other. Look at this bit. It's like, is that even connected? No, it's not connected. It looked connected from back here. I was like, does it loop around or something? But it's just a blob that's almost connected. What about that one? Is that one connected? Look, these look connected, but they're not. You'd really think that was connected if you were just looking at this from there. How about these? There's a lot that are almost connected, but not quite. Look how narrowly that's almost connected. And then up here, we get these waves. So that's pretty cool. This on its own has a sort of optical illusion-like texture. You can, if you look at it the right way, sort of, it looks 3D almost, like it's a wavy, like that wavy metal that's on the exterior of some sheds and stuff. Anyway, let's see what else is going on here. Well, we got to try putting it on both here, and that made it a little too crazy, but how about I flip the inequality for this one? Now it's a little more digestible, and we sort of have different little islands, which I like when that happens. So I might want to mutate this one a bit more, because when we have different patches, some of them look almost like eyes. Some of them just look like weird little islands. When we have different patches, and this one, it's another one that looked like it crossed over, but doesn't quite. And so these little islands are unique, and I like when that occurs because then we get little distinct shapes to observe individually, like we're explorers going down a sea and seeing what islands we come across. And by the way, to look at the things here, someone said, what are permutations? Well, like I said, I'll do my official intro to it on another day, but just to give you a really quick sense, let's show the Wikipedia. It's selecting out of items. Let's say you have some amount of items, and we're using the first type of permutation here, which is, because a permutation can also mean a way of changing two of them, sort of like going from one of the first type of permutation to another. An arrangement of some of these things in an order. And so, for example, we have 3 colors here, and we are ordering the balls and stuff. And anagrams of a word are permutations. And in general, they relate to factorials with a formula I showed a little earlier in the stream. Someone said factorials of non-integers is nonsense. Well, given that they are based on factorials, it's logical to consider it equally nonsensical to have a factorial of a non-integer or to have the permutations or combinations, which are formulas derived from that essentially. And so you could say that factorials of it is nonsensical, and perhaps it should have another name. Maybe they shouldn't use the exclamation mark. But the gamma function does have unique properties that behave well while having the factorials correct at all integer values. And it's I haven't made an episode about the gamma function yet, but it's a very logical extension to factorials. So you could also say that imaginary numbers don't make sense, but they're a very logical extension that works well. And so since we have a logical extension that works well, they allow us to play around with it here on the graphing calculator. So perhaps it should have a different name, but just think of it as a generalized permutation, one where we're following the formulas and their logical extensions rather than using the word permutation to describe something happening in the world. And we do know a lot about equations by seeing these in-between points. Like the gamma function teaches us more about factorials, even if we have at that point lost some of the real-world analogies. So things are only as nonsensical as you let them be, but still, you know, we can consider it a little nonsensical to some degree that they use the same symbol. Perhaps it should have a slightly different version of an exclamation point or something. And someone noted to zoom in because it has more detail than can be plotted. Yeah, I do like looking at the large scale sometimes, but it does lack detail. So when it gets sort of fuzzy or looks sort of like static on a TV or something, that's a sign it is not getting all that. And they give us the clue right here, but sometimes you're stuck with that clue unless you go really close. And even when you get the clue, you're at a state where you can kind of tell what are the staticky looking bits that might not be accurate and what looks more accurate. With that said, it's good to look at all these from several scales. And here we have the formula. Someone, Jared Schreckengast, wrote the formula I mentioned earlier, which is the way essentially that permutations can be described in terms of factorials, by far the simplest formula for them. And Mike Bolt asked about the prime flip proof. I'm still in the process of responding to stuff, which I have promised myself and you folks I will do during this transition to grade -3. I will catch up on responding to people and such. And so sorry I have not read through the prime flip proof yet, but I will as soon as I can, Mike, and get back to you on that. Right now I'm a little busy with stuff that I'll have a lot of fun videos coming out in the near future, and some of them are related to my finale of grade -2, which we are near the end of. Now, anyways, we are going to look some more at the graph, so feel free to continue commenting, but as you know, I will only look at them every once in a while. And we are going to see what happens first, just when we use tangents anywhere in the mix, which are a different type of trig function with much different behavior than sines. And then we are going to go back and simplify things a bit. Instead of having tons of trig functions, why don't we say we have x, y, and let's make this one a sine again. And what if we're counting that one by x, y? These may cancel out a bit, so what if I add? Well, now I have these bridges, sort of, creating these stripes. And some of them, this one we can get to a state where we see all the detail, but some of them have infinitely deep sections where we can't even get all the detail no matter how far we zoom. Now, here we have some that may cancel out a bit too much, so maybe we'll just stick with one sine or something in the mix, and I'm actually going to have the sine be over here and fiddle around just a bit more with different combinations of x and y, and perhaps a. Let's let an a be in the mix so we can mutate them a bit. Well, now we've flipped something in an interesting way. We used to have the more checkerboardy thing up in this quadrant. Now the more checkerboardy thing's there. We've also filled in the gap over here that was sort of missing, but up here we have a new massive gap. Here is the most interesting bit, where this bit is like waving around in I keep thinking they're intersecting, not even intersecting itself always, seeming to intersect itself. That's weird that they approach each other like lines and then they're like, nah. So there we have those, and when we change our a, this will mutate a bit. This is when a was 3.2 actually, sort of random. Here, oh, we can shift it around. Now we're back where the checkerboard thing's up there. We can sort of like mutate them until the checkerboardy bit is the bit down there. And this bit's coming around in a stripe. That's strange looking. Okay, so now let's create a clone of this that's slightly different and see it and a friend. What if I subtract there instead of add? Now, in a lot of ways, these are going to do their own different things, but some aspects of them are going to line up. What happened there? That really looked like it touched on the way there. So this one, sometimes they must touch when they look like they don't, because this one actually does end up touching. Dependent on the A. And now let's change what it and the friend do. So here, let's have just x here and some combos of y over here. And let's say y gets to be squared. Whoa, so that did a lot. Whoa, up here it's having a lot of trouble. Whoa, what's going on here? This is like breaking Desmos. It's straight lines, but it can't compute all the straight lines. So they're like graying out up here. Wait, no, they actually do? That's weird. It stops having equality bits that are like, on the outsides when it's exactly equal. The shaded in is when the equality, or the inequality part of it holds. And then when you zoom out enough, it like breaks Desmos a bit. Sometimes you get really cool patterns in them just trying to interpret the data and not being able to. Like, look at this. Oh, and this guy over here. I think this is the fella they call Bernard. Believe it or not, that fella recurs so often that he's gotten a name. Where is this right? What does he look? Yeah, look, there's Bernard over there, I think. Is that him? Yeah, he's getting his little shape. So for some reason, this thing is that it? It looks a little different here. It looks like a flipped version. Is this Bernard's cousin or something? But for some reason, this occurs a lot in their, when they can't handle the data. You get that fella. And this looks like a flipped version of it or something. Now it's gone. When we're up here, we have that. And yeah, it's sliding over. It's always over there. This is a weird way they're trying to interpret it, and getting that out of what looks like straight lines when we're up close. So this one's pretty crazy, but we can't see much of it because it glitches out at most scales. So I don't know if it'll make it better or worse if this one's squared too. This one's gonna have its own glitches if I zoom out. Like this time we get this sort of glitch when we zoom out. Even though I know it's not accurately portraying the graph, those parts still look cool. Now, the squared was doing a little too much, so we're gonna have to remove that there. But perhaps we could put one over here. Okay, we're gonna get rid of the exponents for now. And as one more experiment with these signs and stuff, what happens if this whole thing is in a sign? Whoa! Okay, so that did a lot. So let's investigate one quadrant at a time, because we sort of have to be at different scales to investigate them. These quadrants we can see from here, see that they're forming that pattern. But up here, we have to zoom in to see that, and this I think is one of those infinitely dense bits where if I zoom in, I'm never going to get to the point where it can see it all. There's too much going on up there. But what about closer to the origin? Let's go back down there. Yeah. So over here, we get these strange coils. We've seen these come up a few times before. When we've mixed just factorials and these things could phrase the whole thing because of the permutations being in terms of factorials. So when we just played with factorials and signs, we got somewhat similar things, although with this, we need less terms to go crazy because of how the permutations already have a few things built in. And ooh, we get dandelion. You want a little cat meow? Here's your little cat meow of the day. Oh, it's hard to point it at him. Dandosaur. There's his tail. Dandelion. I'm trying to aim for him, but it's hard to see. There we go. There's my little dandelion. Here's your little cat meow for the day, because dandelion's so nice. I was trying to expand this. I just dragged it. Never mind. This is the cat meow for the day anyways. Dad's a good little dandelion. Oh, he's saying hi to them? Yeah, he's saying hi. Dad's a good boy. So I've been camping out back, and the cats jump into the tent. It's really cute. There's a little flap on the tent, and the cats jump over the flap to come in and say hi. Oh, Dandelion, you're stepping on it. I don't want him to like end the stream or something. Okay. Don't worry, I'll keep petting you, Dinosaur. Okay. He opened something. He stepped on whatever opens this. Okay. Good thing he didn't end the stream. Dandelion. Okay, he's still here. But you might not be able to see him, but trust me, I'm petting him still. Now, here, let's zoom out and change it a bit now that we've gotten our cat meow of the day, or our cameow, depending which term you want to use. Now, first of all, I want to just sometimes remember, we're going to get a much different view if we flip these. What happens if we flip these? Now the coils and gaps and stuff look more like this. So flipping the inequality sometimes will be useful. Flipping the x's and y's can also do similar things often. So here, let's try some other mixes of these. What if only that side had sine? Now these coils sort of trickle off and just end over there. The coils get cut off by this curve shape. It's like this curve ate a slice out of the coils, ate the rest of them. And down here, I don't think you get anything. Up here, you get everything. And so this is the most interesting part. But it's strange the way they cut off right there. And if we zoom in, I think it keeps going. I think we keep getting more and more of these no matter how much we zoom in. That's why it looks like dots. It's actually lines. Now, let's try giving this a friend so we can edit two that are similar. And this one, what we'll try is simply changing where the A is for now. And if I have a set to 1, these are going to do the same thing. So it's almost like an alternate universe version of this more than just a friend, because here they're the same, and now we can see them diverge from each other. But they are linked together still, it seems. Well, to a degree. No, they're doing somewhat different things here. But here they do come back together for a minute when it's at 1. What about negative 1? Negative 1, they're not together, but they look sort of like flipped versions of each other, maybe. You see how that looks like an upside down that? You know what these also look like? This flower right here. Do they have any that still have that? Because this right here are these guavas. And these are not quite ripe, but they're almost ripe, and I'm really looking forward to it. They're known as feijoa or feijoa in some places because it's not the same type as some other common guavas. This one's also called pineapple guava. But these big guavas are almost ready, and I'm looking forward to it. But they have something that the flowers, I'm trying to see if they still have any flowers left because they're mostly all at the fruit stage. Looks so similar. Oh, here, yes. Look at this. Oh, okay. It came off. That's okay. There's enough fruits on the tree. This one's probably too late to go anyway. Now, the petals are gone on this because the petals are edible. So something or someone ate off the petals because the white petals actually are fully edible, not these outer petals. But doesn't this look similar to this? Look. We graphed it. That's crazy. You know how you graft the other type, like G-R-A-F-T? You can graft trees to make new fruits. Well, this might be one of the first times someone has graphed a fruit in this way. So, success. May our guavas be as large as this when they're ripe. So that's pretty neat. I told you we'll find things that we can put in human terms that look like flowers or stuff. Now, these friends were diverging quite differently because of the A. So for now, let's try no A for a moment. And we're going to just flip the X and the Y here and see if that makes them fully complement each other. So yeah, now they're symmetrical in that way. And across the X equals Y axis. Now, let's see. How can we adjust these? Maybe this one's X minus Y or X divided by Y. So this could be in the opposite order. So now, and let's actually put these back in the same order so that we can see the differences. So now they're going to be doing slightly different things. That one's doing that with that little thing connecting these two. That's like a little cobweb in between two of the flowers. And, or more like it's like a little hammock that a little like ladybug laid out or something. And then this one does that. We got our downward facing guava flowers. And what if we had divided instead? Division always, kicks it up a notch. First, let's just see what happens here. Well, now we get some things similar to these coils that were on their way to the guava flowers, but some weird different patterns as well. Check out each quadrant for a minute, see what's going on in each quadrant. This one has all these different rays coming down of spiral, or not quite spirals, but curvy things. Now, here, let's try if we had some division involved in this side. So we're going to take the sign away for a minute. We'll put that back when we're ready. Now we're back to a slightly more regular state, even though we have the division there now. But what happens if one of these gets division? Ooh. What if they both got division? That's more boring, actually. And what if that one got division? Now, what if it's them divided and just a constant? Well, that just spirals around, not as interesting. Maybe it's because we have that right there. What if that was flipped? Nah, this is just not the most interesting one, even though that one got a curvy bit. What in general happens when we have x and y there in a constant that we're changing? Well, let's zoom in and see how this one changes with the constant. So mutates around a little bit like that. And let's see what happens. This just had the y over there. So let's see what happens when we put x there. That would be symmetrical, but what about both? Well, maybe we want that to be a little different then. And, well, that's interesting. I think we need to put back the sign. Now we got sort of like a flat little sandwich that looked like the flower from before. And let's see right here. What if we have it on both? Now they're starting to get a little more predictable, actually. And maybe that's because we have the constant there. So maybe we do want to keep x and y involved in there. And now we have that interesting pattern. I forget if we've... Oh no, I don't think we've seen this one before. These are crossing over sort of unpredictably. Whoa, that looks like an optical illusion. Looks sort of 3D. Here, what happens, hard to see on the bigger scale, but these quadrants we can sort of, well, at least that quadrant we can sort of tell its pattern. This one does a little weirder stuff and then gets kind of normal. This up here is much more wavy and weird. All right, that one's interesting. Now, what'll happen if we take this to one further level, and that further level is nesting this within itself? So what if we have the permutations of these permutations on just those numbers multiplied? We also need to say what that side is, but let's say it's y greater than or equal to. Well, now even without the signs, we start getting crazy behavior. Over here we get like ups and downs and a sort of infinitely dense barrier. A lot of unpredictable stuff there. Some things are following exactly on the lines where they cut off, exactly when we're at an integer. And let's try some other ways that we could have this nested inside itself. Here we get these fellas and these things. They form sort of this checkerboard-like grid, even though they're not fully filled in. And down here it sort of disintegrates before it hits this thing. This is like the lava, and these are different things flying by, and these ones got too close to the lava. And this is, somehow the lava has a cliff. So, now, this is already doing a lot. What if one of these was a constant? Oh, and there was a zone where it like seemed to solidify. Why was it at 5 that it seemed to solidify and get all filled in there? Does it do that at all integers? Well, this one is just gone. And now it like came back, and at 3 it's solid. That's really weird. Look at this. So if I'm at 1, it's like solid. It's like a normal, just skewed grid over here. Although it looks normal but skewed, but I wouldn't be positive that these sections are straight because at least at the end they're not. They become curved at some point, or maybe have been curved all along in a really subtle way here. So I would need a really long ruler and a really big computer monitor to check. And here, if I'm at 1. Now A is in between, and they start disintegrating, sort of. And at 2, they're gone. But there is like little bits poking above the axis, but barely anything in that quadrant. Just these little bits on the edge. And then I go to 3, and they're back. It's every odd integer they are solid, and every even one they're mostly missing. That's interesting. Ooh, and some of these states are pretty neat. Whoa. Hard to believe this is just one equation. Or one inequality. I often call them equations, but I gotta remember equation has equal in the name, and calling this an inequality is more accurate. So, but also an inequality seems not to describe this, because inequality, like the word root there, is not equal, and this can be equal. It's like, you know, we need a shorter term than greater than or equal to. That should get a shorter term. Same with less than or equal to doesn't need one. Just great. No, they should both get one. So, well, I guess you could say a synonym for this is greater than or equal to is not smaller. So I guess not smaller is the shortest way to say that. So here, that's one way of nesting it. And let's try some other ways. Well, we still have an A in the mix. What if we just have this side be the A, and over here stick with our X's and Y's? That's looking a little crowded up at this value. Oh, not over here. These ones curve over in sort of an optical illusion-like way. We can see them curving around. And let's see. These ones are doing interesting things. And can we get that zone less crowded by changing our A? Yep, way less crowded. At 0, it looks like one of the things we had before. And once again, zooming out will look cool even if it doesn't properly display exactly what's going on. We can see some big picture phenomena. Like out here, they're at least getting the big and or obvious or easy to calculate bits. Although some of them they just glitch out with. I was just seeing how we could make it glitch, but now I'm at a really crazy scale. Oh no, oh, whoa, even crazier, this direction. Okay, getting back to normal scale. Okay, here we go. And now let's see what other combos we could do. Well, pretty crazy, but we gotta try nested with the trig functions. And I think I should check if, because I am like in a front yard that's shared with other people, and it's better to live stream out back in the classroom. Let me check if the neighbor's still playing loud music. I'm just gonna run around the corner of the yard. And while I do that, we can watch a little animation. We should have our animator ready on our A. We wanna make it really slow, and we wanna give it really small steps in a manageable range. First, let's see what range stuff is looking cool. We'll just go from like a -3 to 3 and make a smaller step if it lets us. And now we're gonna change it a bit. And here we're gonna switch these a bit. We're gonna have X, Y there, and that's the second one. So, and XY did change things also, so we're going to give it a friend, and this is going to have these swapped. And so there it is, and its friend. Whoa, look at this strange grid they form together, sort of. And I will put this on animation for 1 second while I run out to the other corner to see. We may move over back to what's currently my camping zone for fun. Okay, hopefully the animation's not too glitchy. I'll be back really short. Okay, it is quieter out there now. I am going to relocate it back there. I do have to really quickly run to the bathroom, but I might as well relocate you here while we're at it. So now you can see if a squirrel runs by the back fence or something. Last night there were raccoons. There's this younger batch of raccoons, and they're like sort of still figuring out how to do the raccoons version of foraging, which involves like hunting around yards to see what there is. And the raccoons, one of them got really scared, one of the younger ones, when I came near it. Normally the bigger ones are like, you want to get near me? You want to fight? They're like really aggressive. But this little one was super timid, and it ran away. And it ran back along this fence, and I heard it knock over a clock. I didn't see it or get it on film, but I heard it run by and heard the sound that I've known to associate with when a clock falls off the back there. So now we've had squirrels knock them off and raccoons. So this is a pretty cool animation. I'm going to switch what we got going on here real quick, and then I do have to run to the bathroom for just 1 minute. This is our intermission for the day, but it's an animated intermission. And what we'll do is we got a lot of X's and Y's going on here. Will it work if we make this one divided by? Sure. And we'll make this one the opposite divided by? What'll that do? Is that just the same thing mirrored? Well, maybe I'll make that the same, and these are flipped, so that will do a slightly different mirror, if anything. And maybe this side gets one. That gets an X, and this gets a Y. That looks interesting together. So, I'll be back shortly. Here's your new animation. Alright folks, hope that animation looked cool. I missed some of the animations, so I'll have to rewatch my own live stream later, I guess. Hopefully it didn't pass by a really offensive shape that I missed. Okay. These are interesting at different spots. We have like this ray of light shining through, it looks like. Shining through, or a lot of rays coming from over this direction, or more like radiating from the origin. I like this checkerboard-like thing they're making too. It looks like somebody like painted a checkerboard with like just slashes of paint. Now, while I fiddle around with a few other options, let me check out our chat for a moment. And Jared noted if I set the shapes a equaling pi, they'll touch. A equaling pi, due to being irrational, won't come up on one of the sliders. They're rational numbers on some scale, like some step. Right now we're doing 1/100th as the step. In fact, I wonder if they'll let you do fractions, because I bet we'll hit more interesting stuff if our step is a highly composite number, like 1/60th will probably, if they let us. Actually, even though it might approximate it, so I'm not sure, that might hit more interesting things than 1/100th. So we'll try that. But eta pi is just, I'll have to set it for an individual one. But we can always try that for some of these. I don't know which one that was referring to. And some other cool notes. Some have hyperbolic asymptotes. Different interesting things going on. And lots of good ways of describing these. Somebody asks, can I think of a formula that will make the graph distorted with all values in y, the square root of a and or x, plain and or times maybe, or and for x, plain values of a? I'm not sure exactly what you mean. So if you describe that more, maybe I'll try. Anyways, let's try some other combinations. Well, first we've been leaving the sine out for a minute. I know it's doing kind of a lot, but let's see what happens when I throw in something trigonometric here. Well, here we get this wavy thing. And now we're getting sort of like a mix of some of the patterns we'd seen before. We have, this is just one graph, that's crazy. We have these diagonal things, these little quadrilaterals that are really dense. This one has a line cut through it where the colors change. But these are really dense. It's sort of an optical illusion that from a certain angle, it looks like it's just extending, and you'd expect that, even though you can't fully see it. But you're like, whoa, it actually completely flips the colors across this line. Just the shapes maintain the same, so it sort of looks like one continuous thing. And so we get shapes like that, and then we get these shapes that are partially filled in. This one was like almost all filled in right here, but not quite. Look right here. There's like a little gap, or maybe that's part of that one. I don't know. But we get that shape. And then this one is like partially that. This one, it's like the top like 60% of this one is shaded, meaning the inequality holds, but this part isn't. So this one has an interesting mix there. What about up here? We get a little egg. That's lucky. Whoa, this is like a little egg is heading toward the portal. And here we have a mix of nice little boulders and strange portals in between the boulders. The boulders becoming more like these shapes that we saw similar ones to before, but these ones are more egg-like. Then here we get this little wavy stuff. Here, this is like this black hole zone is emitting these rays. And this ray turns around and goes down there and joins all this. So we have a lot going on in these. Like, look at this one. This one is like, it's having trouble getting it all. How far? Okay, here it says it gets it all. Not anymore, because then it went to that. But this gets cut off by that line and switches, and then cut off by that line over there and switches. There it turns into a little like bulb thing, like a little spade shape, like on the cards. And there was our egg. So a lot going on in this equation. Over here they sort of trail out as little like spiky paths. Up there a lot is going on. And here, what's going on? Here they like set, there's a lot of blank space between them up here. This is a lot going on in this graph. And you want to know the good news? This is just for one value of a. So let's see how this mutates. it's hard to know what scale to look at it on because I want to be zoomed in to see it right, but then we don't even see things like that. These have gaps between them up there. This is a crazy graph. Okay, so let's try and fiddle with A. Here's as A shrinks toward 1. This is really weird. Like, look at down here. It's passing downward, and like it's like a window onto a checkerboard background, sort of passing downward, but also mutating things. We lost our egg. Things connected. And yeah, we get all sorts of weird little spots where things cross over each other in wavy ways. So that one's pretty wild. Now, let's see. What if we go extra crazy by nesting that in there? Another divided by. Actually looks pretty similar. But now we get a few little separate blobs. Like, look at this tiny little one right there. And now let's change some things going on here. We have the sign there. What if we have the sign in one of the other places? But let's also just simplify this again first. We're going to go x, y, x. At that A, this one's missing a lot down there. How can we make this more interesting? We're just going to layer it a little simpler. We're going to go that, layer that right away, and then the opposite of the one I'm putting over here. So now we've gotten a little simpler before we complexify it again. And now we're going to test different places of putting a trig function around it. Outside all of that, we need to be at the right spot to see all the craziness. But when A is at the right value, it becomes crazy again. And then if I had put the sign here instead, then what's wrong with that? What's wrong with my parentheses? Sign requires one argument. Oh yeah. Sign of this. Do I need like another parentheses there to make it work? Okay, wait. I need to rebuild this. I got confused. So the permutation of sign of the permutation of x and y, and then an x. And is that enough? No, that's confusing it when I'm putting it in here. It's not like I'm putting them between it, or I'm not phrasing the parentheses or something right. But anyway, we will try some other combos. Are we allowed to stack them like that? Here we would need x, y, and then we would need something like that. It requires 2 arguments. Which one doesn't have 2 arguments? It does have 2 arguments. There's this chunk, comma that. And this one has this, comma that. Why isn't it considering that 2 arguments? I don't know. Something about the structure was going weird there. It worked before when we were doing it. Let's just copy one of the times it worked and go from there. Because I don't want to spend the time figuring out exactly why that didn't work. We'll just copy one that worked and adjust from here. So are we able to put this in both of these? This one's going to be yx instead. Okay. So, and then this side we're going to make x, y, and then we're just going to add some a's to different places and see what this type of thing does. This type of thing being ultra layered. And let's add a to the different spots. It could be one at a time. We'll just have one A in the mix at a time. Over there, not as crazy. What about here? Now we're getting some interesting stuff. Look at this like little mini checkerboard zone that like checkerboard's getting smaller and smaller. It looks sort of like you're on like a curved skate ramp or like in a curved sewer or something. And this part is checkerboarded going off into the distance. Sometimes you not only get things that look like things, you get things that look like 3D things. So this one has some interesting states. What if my A had instead been in one of these? That's if it's in just one. What was going on here? Here we have a sort of, when it's 0, we get something sort of straight upward going on here with this slice. And these are hard to see at the right scale, but now it's helping because I'm concentrating all the stuff close so then we can zoom in. All right, now what if my A had been on one of each of them? Well, that's if it's on the same one. Well, here we had like a little interesting lake thing right here. This little zone is strange looking. It comes off of here. And there's another one, but a lot more circles. Well, not quite circles. Not even quite ovals. Now, where next? Let's move the A on an opposite one this time. Alright, now what we're going to do is we're going to make it extra colorful, we're going to simplify things, and we're just going to have one of them. And then we're going to make some friends. And we'll put an A somewhere. So this one isn't doing that much yet, but we'll see how it plays along with some different variations on it. Does that help? Maybe. We'll try it like that for now. And to play on a variation here, we'll have one where they're both sine, and we'll have one where only that one was sine. Now we have 3 friends that have similar equations, but depending on where our A is, might do very different things. And to make it more visible, let's make them slightly different colors. Here, red, green, and blue. And the red's blotting things out. Whichever one I put on the bottom looks a little darker out of all of them, so we can adjust that. This looks like an interesting painting or something. And this is where the paint spilled on the edge of the canvas. This is like paint currently falling. And look, we got a bunch of 8s. We're in an 8 factory. They look more like sideways infinity symbols, but from this orientation, they're 8s. Although this one looks like an hourglass. We built a little hourglass, but it's a broken hourglass. All the sand spilled. So, one comment, by the way, is wondering what if continuous maths for physics is actually an approximation because we live in a discrete world? Well, we don't know, but we also don't know the opposite. What if discrete math is somewhat an illusion in reality and the real world's all continuous? Or maybe both, or maybe neither. That would be the weirdest, but we don't really know all of the ways in which math connects to physics. We're still learning many of those things. And here, these were interesting, so let's adjust our A and see how they move together. They're sort of all sliding over here, but at different speeds. It's a race. Who can get over there fastest? Run! So, those were somewhat neat, but we can create more interesting trios. Let's keep up the idea of having our variation relate to where we get the sign there, but it seems a little random what we have here. We're just going to put y instead of xy there, and we will do something. Maybe we'll put multiplication here instead. And actually, you know, I said we would just use one of these, but maybe we'll use two permutations. Maybe this will be the permutation with X and Y. And now let's see what happens when we adjust our A. This is a pretty wild landscape, so we're going to zoom out to see some of the big picture. This one, sometimes even more than quadrants, we have like 8 zones, although sometimes just a quarter of it does the same thing. But with these colors, we can see quite a distinction of like this zone has a lot of red. These ones are where blue sort of comes in for that version of the equation, which one's got signs. This one is pretty checkerboardy, and this one is a whole series of eggs in this strange ocean. And now let's try another combination. So, or another permutation, because combinations are a similar but different one. For fun, even though we're not mostly doing combinations today, let's see what happens when we make one a combination. So let's see like the difference on some of these. This was permutation. There's combination. That's a pretty neat equation right here, or inequality. We get these things that are spiky. Are they touching? I think. Hard to know. And we get these things, which form a checkerboard-like thing, but this time their edge gets this little rounded bit, or joins another rounded bit. This should be the board for chess 2. So now let's see just real quick if we had switched both of these to combinations. And let's just make them all combinations real quick for fun, even though it's mostly a permutation stream. Let's see how these ones evolve, and we can watch it for a second so I can analyze it as it moves. We can see the animation is quite glitchy when it's like this, but we're seeing it inch along a little bit at a time for different phases. And so remember that when we have a slider on A, it's almost like we're watching cross sections of a 3D graph where the amount of the third axis is changing. Now we're seeing different slices of that. And we have a comment recommending from Maynard mentioning Norman Wildberger. Sounds interesting. Maybe I'll read some of that later. And we have a variety of other cool thoughts. And someone apologized for a comment on a short from before. That's okay. Don't worry if... Definitely comment whatever your thoughts are at any point. If there's ever a reason why I seem like I disagree, or if I don't keep up any content for various things like that, don't worry. I'm not offended by anyone's comments. They're all good. All my combo lords. The only comments that offend me are when someone says something about math really confidently that's wrong. Those are the ones that offend me, when someone's like, actually so-and-so, and it's not correct. Because they just bother me because I think they're misleading people. But apart from that, which I don't think any of my main combo lords are doing that, comments that clarify things or leave thoughts about ways you may interpret things differently are definitely good. So here we have a variety of different things editing and smushing together. This is interesting. This is sort of like people are playing a game currently on this board. This is 2 players taking turns in this really surreal game. So we're not going to be doing too much longer on this stream. Let's see how long we have been going. I can't even zoom over there easily. I accidentally opened the stream and I don't want the stream open. I want to be looking at the stream. Because when I opened the stream, an ad started playing. I don't want that to happen. I want to... No. Okay, that time it worked. No ad. Anyway, I don't think we are going to be live streaming for that much longer. It's been a little over an hour. Sometimes we go hyper long, but I'll do a few more arrangements of these shapes, answer any remaining questions or thoughts from people, and if anyone leaves while I'm wrapping up, make sure you are also checking out the bonus videos I've been dropping on this channel, as well as that you're tuned into my main combo class channel, because that's going to have my next full episode, which is the whole grade -2 finale. Grade -3 will have begun later this month, or possibly the beginning of next month at probably the latest. So let's fiddle around with a few more options on this before we wrap up. And let's see what will be good. Let's change them back to permutations, because we can do another live stream next time we do our graphs, which is usually every few live streams comes back to Demotro's Graph Lab. And we'll do a combination-centric one at some point later. Right now, I mentioned permutations in particular, partially because I was worried mixing them with combinations might cancel out in ways I didn't realize because the formulas are similar, and partially because there's enough craziness we can achieve with these. So let's now try a few last things, and one of our first last things will be, well, what about a few other types of trig function? Tangent might be too crazy, but let's see what it does. And then, even if tangent's too crazy, trying stuff like secant is a bit different, and trying stuff like hyperbolic sine is a bit different. So we'll experiment with each of those as well. So let's see what this thing does. We might need to zoom in more. Okay. Some bits don't seem to be changing nearly as fast as other bits. So that's pretty interesting, but tangent, like I said, can be a little too wild sometimes. So this is like the painter made a really crazy painting in an angry mood, and the paint splattered everywhere. Let's go to secant and tidy up our painting. And then we'll see if hyperbolic sine does anything fun. And let's look at them not all at once. Let's go back to one for a moment. This one mutates sort of like that. And this one mutates sort of like that. And this one mutates sort of like that. And now I didn't have one where we also had the trig function on this side, on the outside there. So let's see what this does. And let's let them all have it. They all get secant this time. Well, that does this wacky stuff. Let's make some friends that are similar ones. Like, let's copy this all. And we are going to have one. Whoa, that's a lot going on. We're going to have one be sines on all this stuff. And one be cosines that are going to probably do a really similar thing, but these two will be friends. So, let's see what those do at different stages. All right. Pretty crazy. Now, I do think I'm going to wrap up our graph stream soon, so let's just put all these on and overload the painting. This is the craziest state of our painting, if it can even handle anything going on. And in general, lots of cool stuff to see with a few simple equations. So I hope you all enjoyed the little graph stream. And like I mentioned, stay tuned into the combo class channel and the bonus videos on this channel that have been coming out. For my Patreon supporters, there will be a long time overdue couple things coming in the next day or so. And the finale is the main thing I'm working on. So I'm still doing a camping experiment out here. I will be in this tent again tonight. Hopefully the cats will join me again. And I hope you will join me again in whatever form the next content is. So thank you.